Each of the different selections or groups or sets, those can be formed out of a number of objects taken all or some at a time is called a combination. Each of the different selections or groups or sets, those can be formed out of a number of objects taken all or some at a time is called a combination. Come to an example. Suppose we have three objects A, B, C. So let's find how many different groups can be formed out of the three objects taken two at a time. Okay. So taking AB, we can have a combination. Taking BC, we can have another combination. And taking AC, we can have another combination. Only three combinations are possible. So the combination AB will give you two permutations. One permutation will be AB, another permutation will be BA. Similarly, the combination BC will give you two permutations. That is BC and CB. Combination AC will give you two permutation. Combination AC and permutation AC and permutation CA. So in combination, order of the objects is not taken into consideration. Note it down. In combination, order of the objects is not taken into consideration. Write down a theorem. The number of combination of n distinct objects taken r at a time is denoted by NCR or CNR or NR, which is defined by NCR is equal to n factorial upon r factorial into n minus r factorial. NCR is equal to n factorial by r factorial into n minus r factorial. So 5C2 is equal to 5 factorial upon 2 factorial into 5 minus 2 factorial. This is equal to 5 factorial upon 2 factorial into 3 factorial. This is equal to 4 into 5 divided by 2. This is equal to 10. Similarly, 7C3. 7C3 is equal to 7 factorial upon 3 factorial into 7 minus 3 factorial, which is equal to 7 factorial upon 3 factorial into 4 factorial, which is equal to 5 into 6 into 7 divided by 1 into 2 into 3. 2 3 just 6, 6 cancels, 5 7 just 35. Is it clear? Okay. NC0 is equal to NC1, 3NCN equals to 1. Second deduction is NCR equals to NCN minus R. The third one is NCX is equal to NCY implies X is equal to Y or X plus Y is equal to N. Fourth one, NCR plus NCR minus 1 equals to N plus 1 CR. NCR plus NCR minus 1 equals to N plus 1 CR. Fifth one, NCR upon NCR minus 1 equals N minus R plus 1 upon R. Sixth, NCR equals N upon R into N minus 1 CR minus 1. Seventh, NCR equals to R plus 1 upon n plus 1 into n plus 1 CR plus 1. 8th NC0 plus NC1 plus NC2 plus up to NCN equal to 2 raised to the power n. 9th NC0 plus NC2 plus NC4 NC1 plus NC3 plus NC5 equals to 2 raised to the power n minus 1. Okay. So guys, we'll prove it one by one. Come to the first one. NC0 is equal to n factorial upon 0 factorial into n minus 0 factorial, which is equal to n factorial. You know, 0 factorial is 1, n minus 0 factorial, that is n factorial. So n factorial cancels, which is equal to 1. Come to the second bit. NCR is equal to NCN minus R. So start with the right hand side, sorry. Right hand side is NCN minus R. NCN minus R equals n factorial upon n minus R factorial into n minus R factorial, which is equal to n factorial upon n minus R factorial. N cancels, minus upon minus R plus R factorial, which is equal to NCR. NCR, that means we can write 5C2 is equal to 5C, 5 minus 2, that is 5C3. 7C4, we can write 7C, 7 minus 4, which is equal to 7C3. Okay. Then come to third bit. NCX is equal to NCY. You see, if x is equal to y, then there is nothing to prove, because 4 is equal to 4, 5 is equal to 5. If x is not equal to y, then we can write NCX is equal to NCY can be written as NCN minus y according to the previous one. So x must be equal to n minus y. So x is equal to n minus y. This implies x plus y is equal to n. Is it clear, guys? Did you understand? Hello? Gayatri? Yes. Okay, let's move forward. And the next one is, I think, fourth bit. NCR plus NCR minus 1 is equal to N plus 1 CR. NCR is equal to N factorial upon R factorial into N minus R factorial plus NCR minus 1 is N factorial upon R minus 1 factorial into N minus R plus 1 factorial. Now we have to take the LCM. Okay, R factorial, R minus 1 factorial is there. So the bigger one should be taken, which is equal to R factorial, N minus R factorial, N minus R plus 1 factorial. So N minus R plus 1 factorial. So R factorial into N minus R plus 1 factorial is the LCM. Now we have to divide the LCM by the denominator and multiply it with the numerator. If we divide R factorial into N minus R plus 1 factorial with R factorial into N minus R factorial cancels. If we divide N minus R plus 1 factorial with N minus R factorial, the quotient will be N minus R plus 1 and the remainder will be 0. So this is equal to N factorial into N minus R plus 1 plus, similarly, if we divide the LCM by this denominator, then the quotient will be R, N factorial into R. This is equal to N factorial into N plus 1 minus N factorial into R plus N factorial into R divided by R factorial into N minus R plus 1 factorial. This one cancels. N factorial into N plus 1 is your N plus 1 factorial divided by R factorial into N plus 1 minus R factorial. If we consider N plus 1 as the capital N, then N factorial by R factorial into N minus R factorial, which is nothing equal to NCR. This is equal to N plus 1 CR. I hope it is clear to you. Okay, then come to fifth one. NCR upon NCR minus 1 divided by N factorial upon R minus 1 factorial into N minus R plus 1 factorial. This is equal to N factorial R factorial into N minus R factorial into R minus 1 factorial whole into N minus R plus 1 factorial upon N factorial. N factorial cancels. R minus 1 factorial, R factorial will be cancelled and left over will be R. N minus R factorial, N minus R plus 1 factorial. N minus R plus 1. This is equal to N minus R plus 1 upon R. Clear? Okay, then sixth bit. NCR is equal to n upon r into n minus 1 CR minus 1. NCR equals n upon r into n minus 1 CR minus 1. NCR is equal to n factorial upon r factorial into n minus r factorial. You know, n factorial can be written as n minus 1 factorial into n divided by r factorial can be written as r minus 1 factorial into r into n minus r factorial. Okay. So write n by r separately. This is equal to n by r into n minus 1 factorial upon r minus 1 factorial into n minus r factorial. This is equal to n by r into n minus 1 CR minus 1. Clear? Oh, okay. Okay. Thanda, thanda. The next one is NCR equal to R plus 1 upon N plus 1 into N plus 1 CR plus 1. NCR is equal to R plus 1 upon N plus 1 into N plus 1 CR plus 1. Come to the right hand side. R plus 1 upon N plus 1 into N plus 1 CR plus 1. This is equal to R plus 1 upon N plus 1 into, by the previous theorem, NCR is equal to N by R into N minus 1 CR minus 1. This is equal to N plus 1 upon R plus 1 into N plus 1 minus 1 C R plus 1 minus 1. So N plus 1 cancels, R plus 1 cancels, which is equal to NCR. Then the next one is NC0 plus NC1 plus NC2 plus up to NCN is equal to 2 raised to the power n. NC0 plus NC1 plus NC2 plus NCN is equal to 2 to the power n. 1 plus x whole to the power n is equal to nc0 plus nc1x plus nc2x square plus up to ncn x to the power n, taking x is equal to 1. The left hand side of the expression will be 1 plus 1 to the power n is equal to nc0 plus nc1 plus nc2 plus up to ncn. This implies nc0 plus nc1 plus nc2 plus up to ncn is equal to 2 raised to the power n. Clear? Again, the last one. nc0 plus nc1 into x plus nc2 into x square plus up to ncn into x to the power n. So taking x is equal to 1 and x is equal to minus 1 in turn. Taking x is equal to 1 and x is equal to minus 1 in turn. So if you substitute x is equal to 1, you will get 2 to the power n is equal to nc0 plus nc1 plus nc2 plus ncn. Again, if you take x is equal to minus 1, then the left hand side of the expression will be 0 and the right hand side will be nc0 minus nc1 plus nc2 minus nc3 up to minus 1 raised to the power n times ncn. Now if you club these two equations, the left hand side will be 2 raised to the power n. All the negative terms will be cancelled. Twice of nc0 plus nc2, all odd place coefficients will be there. So this implies nc0 plus nc2 plus nc4 equals to 2 raised to the power n divided by 2 is equal to 2 raised to the power n minus 1. Okay. Is it clear, guys? Then come to problems and combinations. Come to questions. Question number 1. There are 25 points in a plane of which no 3 points are collinear. There are 25 points in a plane of which no 3 points are collinear. How many different straight lines can be formed by joining these points? There are 25 points in a plane of which no 3 points are collinear. How many different straight lines can be formed by joining these points? Okay. Come to the solution. This is suppose point 1. This is point 2. This is point 3. Likewise, 25 points are there. No 3 points are collinear means no 3 points lie in the same straight line. You see, join of any 2 points. Join of P1 and P2 is a straight line, and join of P1, P3 is a straight line, and which is different from the join of P1 and P2. So join of any 2 points is a straight line. So number of different straight lines is equal to number of different combination of 25 objects taken 2 at a time. Write down number of different straight lines. Okay, Gayatri, let me solve it. I think your answer is correct. So number of different straight lines is equal to number of combinations of 25 objects taken 2 at a time. Which is equal to 25C2. This is equal to 25 factorial upon 2 factorial into 25 minus 2 factorial, which is equal to 25 factorial upon 2 factorial into 23 factorial. This is equal to 24 into 25 upon 2, 12 into 25, which is equal to 300. Yes, Gayatri, you are correct. Then come to question number 2. There are 3, 4, and 5 points on the side BC, CA, and AB of triangle ABC. There are 3, 4, and 5 points on the side BC, CA, and AB of triangle ABC. How many different straight lines can be formed by joining these points. Okay, this is the question. Try to solve it, Gayatri. Hey, not straight line. How many different triangles? Is it 60? Let me check. Okay. Just a minute, guys. Okay, let me solve it. BJ answer is 66. Okay, let me solve. This is triangle ABC. This is vertex A, vertex B, vertex C. BC contains 3 points. CA contains 4 points. And AB contains 5 points. So total number of points is equal to 12. Total number of points is equal to 12. So number of triangles is equal to 12C3. But if you join these 3 points, you will get a straight line. If you join any 3 points of these 4 points, you will get a straight line. If you join any 3 points of these 5 points, you will get a straight line. Minus 3C3 so 12C3 is equal to 12 factorial minus 3C3 is 1 minus 4C3 is 4 minus 5C3 is 10 I hope it is clear. 60, 60, 66. Vijay, Gayatri, is it clear? Okay, let's move for the next question. How many different triangles How many different triangles can be formed by joining the vertices of a polygon? N into n minus 4 into n minus 5/6. Okay, let me solve it. So it will be better if you take the case of a hexagon. So this is a triangle. So this is a hexagon, a polygon of 6 sides. So join of any 3 points gives you a triangle. So all the triangles obtained by joining the vertices of a polygon, some of them are there in which one side of the polygon is the side of the triangle, and second type will be two sides of the triangle. If you join, suppose A, B, C, D, E, F. If you join A, B, E, that will give you a triangle in which one side of the polygon is the side of the triangle, right? If you join A, B, C, another type of triangle, the two sides are sides of the polygon. If you join AEC, no side of triangle is a side of the polygon. So total number of triangles is equal to number of triangles with one side is common. Just a minute. With one side common with side of the polygon plus number of triangles with two sides common plus number of triangles with no side common. Okay. Thus number of triangles with no side common is equal to total number of triangles minus number of triangles with one side common minus number of triangles with two side common. So total number of triangles is equal to NC3 minus number of triangles with one side common. So take the case of, for the sake of understanding, I am taking the case of a hexagon. Okay. Suppose AB is a side which is common. So if one side is common, then adjacent vertices, that is C, D, E, F. Okay. Adjacent side vertices C and F should not be taken. Since we are dealing with the polygon of n sides, if you consider one side as common, then adjacent two vertices should not be taken into consideration. So out of the E n minus 4 vertices, we have to choose one vertex, and that can be done in n minus 4 C1 ways. N minus 4 C1 is equal to n minus 4. So the number of triangles with one side common will be n into n minus 4. Okay. For two sides common, All the three vertices should be adjacent vertices. This can be done in n ways. This is equal to NC3 is equal to, this is the answer. Did you understand, guys? Vijay, Gayatri. Okay. Okay, then come to the next question. A man wishes to make up as many different parties as he can out of his 20 friends. A man wishes to make up as many different parties as he can out of his 20 friends, inviting the same number of friends but not the same combination more than once. A man wishes to make up as many different parties as he can out of his 20 friends, inviting the same number of friends but not the same combination more than once. So, how many friends he should invite at a time? This is the question. Did you understand the question, guys? Did you understand what is the question want to say? As many different parties as he can means the man wishes to make up maximum number of parties. Yes, Gayatri, you are correct. Absolutely correct. Yes, Vijay, you are also correct. Let me explain the answer. Okay. Man has 20 friends and he has to invite the same number of friends at a time. Let us suppose he invites R number of friends at a time. So now the number of parties will be equal to 20 CR. So write down a note point. The maximum value of NCR equals NCN by 2 if n is even NCN plus 1 by 2 or NCN minus 1 by 2 if n is odd. Okay. Since n is equal to 10 years, so he should invite. So the value 20 CR will be maximum when R is equal to 10. So he should invite 10 number of friends at a time. Then move for the next question. How many mixed double games how many mixed double games can be played among 9 married couple many mixed double games can be played among 9 married couple if no husband plays with or against his wife? How many mixed double games can be arranged among 9 married couple if no husband plays with or against his wife? What is the answer? Do you know what is a mixed double game? For a mixed double game, two male and two females are required. So this is suppose net. One male, one female will be on this side, and one male, one female will be on another side. Like suppose Leander Pace, Sania Mirza, Steffi Graf, and Mahesh Bhupati. Okay. So how many people are there? 9 married couple. That means 9 male are there and 9 female are there. Okay, try to solve it now. Okay, come to the solution. One four seven six. Okay, let me calculate it. Maybe you are correct. So for a mixed double game, we need two males. So 9 males are there. So out of 9 males, 2 males can be selected in 9C2H. 2 males can be selected in 9C2H. Okay, once the males are selected, so the wife of those two males cannot be taken into consideration because no husband is allowed to play with or against his wife. So we have to select the two females out of the 7 females, and this can be done in 7C2H. Okay. Suppose male 1, male 2 are selected, female 3, and female 4 are selected. Then match can be arranged like this: male 1, female 3, male 2, female 4, and another set will be taken: male 1, female 4, male 2, female 3. Okay, so 9C2 into 7C2 into 2. And you know NC2 is equal to n into n minus 1 upon 2. N into n minus 1 upon 2. This is equal to 9 into 8 divided by 2 into 7 into 6 divided by 2 into 2. Okay. This is 36 into 21 into 2. This is the answer. Did you understand? Okay, guys, here First session is over. Okay. First session is scheduled from 7:30 to 9. Second session from 9:15 to 10:45. And the second session, I'll start with binomial theorem. Okay. So join at 9:15 exactly. If you have not taken your breakfast, go and take your breakfast and come join at 9:15. I'll discuss binomial theorem in the second session. Okay.